All right, so next I want to talk about a reflection transformation. And so what I'm going to do is let's draw some picture here, and I'm going to try and make the picture just perfectly straightforward so that we can hopefully just redraw this in a second. But I want to make this, oh, I still have my drawing tool on, there we go. So I want to make this something like this. With a triangle, maybe it looks something like that. And so this is going to be our region here. And what I want to do is I want to figure out how do we reflect this. The way I want to reflect it is just across the y-axis. So I want to figure out what's the translation that's going to take this object that I shaded in red and map it to this object. Which I'll draw like that. So it's going to be, it's supposed to be the mirror image. So I want to take the red object and send it to the, let's actually color this yellow or orange. Okay, so I want to take that red region and map it to the yellow region. And so I want to figure out what's the transformation that's going to let us do that. And so what's going to correspond to flipping this image. So just taking it and then flipping it over the y-axis, okay? As if you're folding a sheet of paper from a book. So we want to find T. That corresponds. We want to figure out what's the linear transformation corresponding to a horizontal reflection. Okay. And this is a perfectly straightforward exercise now, but it just underlies that what you really need to understand is what happens to the unit basis vectors. And if you do that, you know everything about the linear transformation. So we need to think about if we want to talk about reflecting 1, 0, if we want to talk about reflecting that across the y-axis, all that's going to happen is we're going to get minus 1, 0. Okay, that's it. So this vector, which I'll color in purple, so this unit vector, say that's, just arbitrarily say that's 1 unit length, that's going to get mapped to, it's just going to be reflected across the y-axis, that's what we get, that's fine. The other thing we need to know is what's going to happen to the unit vector 0, 1. And think about this, if I take the unit vector 0, 1, so if we take this unit vector and we're going to reflect it over the y-axis, we get itself. So this transformation is actually going to fix that vector 0, 1. And so it turns out that T of V is going to correspond to multiplication on the left by the matrix negative 1, 0, 0, 1 times V. Or to say it another way, if you prefer to write this as a linear transformation without thinking about matrices explicitly, this is going to be minus x comma y, right? And this actually makes really good sense from a translation, from a reflection standpoint, right? All you're doing is you're taking your x values and making them negative. Your y values are fixed, right? Your y values stay the same. So that's going to be the matrix transformation corresponding to reflection. Just one more that deals with graphics. There's also what's called a shear transformation. And a shear transformation is where you have, so a shear transformation is where what you're going to do is you're going to take your, I'm going to draw this the best I can, but you're going to take, say, some object. I'm just going to draw a square. It's supposed to be a square. Let's make thicker lines so it's a little bit more forgiving. Okay, so we have our square. And the shear transformation, what it's going to do after you apply this transformation T, the shear transformation is going to take this object and it's going to take this object, and what it's going to do is it's going to just stretch it just horizontally but only horizontally. So you're going to take this and stretch it horizontally. And so what you're going to end up with, it'll actually stretch it a little bit this way too, but you're going to end up with, what's called a shear transformation. Okay, so it's going to look something like, depending on how much you stretch it, it's going to take the object and send it to look like something like that. Actually, just to be, let's draw this just one more time a little better. Since I only drew the square on the right side, let's just draw this accurately. All that this is going to do is it's going to take, it's going to actually fix y values again, but it's going to take your values and it's going to move them over. So it's actually going to fix this vector, and so the rest of it, it's going to look like that. Okay, so that's going to be what's called a shear transformation. So here is a better picture of a shear transformation, and shear transformations turn out to look like, well, not look like, but they turn out to have the formula T of V is AV, where A is the vector 1, 0, so again keeps the unit vector I the same, and then M 1. Okay, so that's the general shape of a shear transformation. Again, frequently used in graphics, computer graphics.